Welcome, learners, to another deep dive here on Wonder Fungi.
Hello, everyone.
Today, we are tackling a challenge that I think sits right at the intersection of, practical use and some pretty deep science.
It really does.
If you've ever explored the world of psychedelic mushrooms, you know there are two, immediate hurdles. The first is just the physical discomfort.
Oh, yeah. The stomach ache.
The dreaded stomach ache. And the second is, the inconsistency of the whole thing.
Absolutely right. Users want more control and definitely less nausea.
Yeah.
And the good news, and this is the really exciting part, is that the solutions aren't just folk remedies anymore.
Right. It's not just stuff people are saying online.
No, not at all. It's verifiable. We can back it up with clinical chemistry and actual mammalian biology. We're here to turn those kitchen experiments into, well, lab-tested facts.
Our mission today is to dive deep into two main methods that people use. First, the filtration method, you know it as making tea. And the second, the acid-catalyzed conversion method, famously known as the lemon tech.
And we have stacked the sources high for this one. We're pulling from NIH research on how our digestive and, believe it or not, our immune systems react to fungus.
An immune reaction.
A big one. And we also have these incredible clinical papers that map out the precise conversion rates of the key molecules in acid. This isn't just theory. This is like the chemistry of the fast track.
And we're going to jump right in by tackling the root of the problem. The reason your stomach basically declares war the moment you eat dried mushrooms. We're calling it the Chitin crisis.
So the symptoms are, they're familiar to almost anyone who's tried this, right?
Oh, for sure. Intense nausea, abdominal cramping, just general, gastrointestinal distress. It can be so bad that it completely overshadows the experience.
It just turns it into a physical ordeal instead of, whatever you were looking for.
Exactly.
And what's so crucial for you to understand is that the nausea, it isn't from the active molecule. It's not the psilocybin making you sick.
No, that's the biggest myth. It is the rigid physical container that the molecule is in. And that container is made of something called chitin.
That's the stuff. Chitin is the main building block in the cell walls of fungi. It gives them their shape, their rigidity. It's basically the fungal exoskeleton.
An exoskeleton. I think that's the perfect way to frame it. To put it in perspective for you, we see chitin all over the place in nature.
We do.
Chemically, it's a polysaccharide, so
Right.
a long-chain carbohydrate. It's sort of like cellulose in plants, providing structure. But chitin is, it's different. Its backbone is made of something called N-acetylglucosamine.
Which is just a very robust, very tightly bound chemical structure. And that is the whole problem.
A robust structure.
Yeah. The classic analogy, and it's a good one, is the exoskeleton of insects and crustaceans.
Like a shrimp shell.
Exactly like a shrimp shell,
Yeah.
or a crab, or a lobster. Think about it. When we cook those things, what's the first thing we do?
You take the shell off
Yeah,
meticulously.
right. Because you know your stomach cannot handle that material, just not equipped for it.
We simply don't have the right enzymes to break down a lot of chitin. It's a dense, indigestible fiber, and it acts as an irritant all the way through your system.
But here's where it gets really interesting. The problem goes way beyond just, being hard to digest.
Okay.
The latest research, and this is coming out of the NIH, it shows a much deeper, more systemic response. They found that eating chitin doesn't just give you a tummy ache.
What does it do?
It triggers a major, measurable immune response in the body.
An immune response,
Right.
like an allergic reaction. What did the researchers actually see when they fed this stuff to mice?
Yes, exactly like that, a defense mechanism. They said the reaction was very similar to an allergic response. The mice consumed chitin, and the scientists saw this dramatic system-wide mobilization.
Wow.
Their stomachs literally expanded, and there was this cascade of immune cells multiplying and sending signals. And it wasn't just in the stomach and the small intestine. They even saw it in the fat tissue.
So the body sees this fungal exoskeleton as like a foreign invader, a pathogen that it needs to fight off, not just digest.
That's it. It's a very different thing from just eating, say, the cellulose fiber in a piece of celery.
Totally different.
And here's the real kicker.
Yeah.
The key scientific nugget for our deep dive today. They confirmed this immune reaction was totally independent of gut microbes.
So it's not about having a healthy gut.
Nope. They tested this in germ-free mice with no gut bacteria at all. And the immune response still happened. This means you can't just, eat more yogurt to fix this. It's a direct, hardwired biological reaction to the structure of the fungus itself.
Okay, so the body recognizes chitin as a threat, and it mobilizes the troops.
Yeah.
But we do have some way to fight back, right? We have an enzyme for this.
We do, but Our capacity is.
Yeah.
It's limited. Humans produce an enzyme called acidic mammalian chitinase.
Yeah.
Or AMCase for short.
AMK.
Yep. It's made by the cheese cells in your stomach, and it's designed to break down small amounts of this stuff.
And what I found fascinating in the NIH findings was this adaptive feedback loop. They found that the immune response triggered by eating the chitin actually boosted the production of that very enzyme.
It did. It's like an escalating defense. The body says, threat detected, mobilize the immune cells, and also ramp up production of our specialized weapon, AMCase.
It's the body trying to optimize, trying to cope with this unusual load of material.
Right. But the most, I think, challenging and interesting finding was how this immune response connects directly to metabolism. This is where the story gets really wild.
Let's unpack this metabolic paradox because it's a little strange. The researchers took mice on high-fat diets, but some of them were genetically engineered to not have that AMCase enzyme.
Right. So these mice couldn't break down chitin at all. They were experiencing the absolute maximum chitin crisis, indigestible fiber, plus a massive immune signal.
And you'd think they would be the sickest, the worst off.
You would. But what's so amazing is that those AMCase deficient mice, the ones having the strongest biological reaction to the chitin, also had two surprising results.
Which were?
They gained the least weight, and they had the least body fat compared to the other mice on the same high-fat diet.
That is completely counterintuitive. So the biggest struggle, the highest immune activation, actually correlated with better metabolic health. What's the thinking there?
The theory is that the immune activation itself is what drives the metabolic change. The immune signaling in the stomach, triggered by that indigestible chitin, might be stimulating the cells to not only make more AMCase, but to also ramp up other digestive enzymes or signaling hormones.
So the body's effort to deal with the chitin kind of jumpstarts the whole digestive system, like a metabolic shock treatment.
Something like that. It's a really exciting area for obesity research, but for our purposes, for you, the listener, the immediate takeaway is very, very clear.
Right. Forget the long-term metabolic stuff for a second.
Exactly. The immediate discomfort, the nausea, it's caused by this super tough fungal exoskeleton that your body struggles with and reacts to aggressively. So the most direct, practical way to stop the nausea is to just get rid of the chitin before you even consume it.
And that is the perfect transition to our first solution, what we're calling the T-test. If the structure is the problem.
Let's get rid of the structure.
The T method is, it's such an elegant and logical answer to the whole chitin crisis.
It really is. It's basically just a process of separation. You're separating the good stuff, the water-soluble compounds you want, from the indigestible, inflammatory stuff you don't.
And the method couldn't be simpler. You grind up the dried mushrooms, you steep them in hot water for a while.
And then, and this is the crucial step, you strain it. You discard the solids. By straining out that material, you are making sure that the vast majority of that hard, chitinous exoskeleton never even enters your digestive system.
And that physical act of filtering just immediately solves the problem we were talking about. No more severe nausea and cramping.
Your stomach is saved from the burden of trying to break down that tough matrix, so it doesn't need to launch that full-scale immune response. It's just a much cleaner, more comfortable physical experience.
Okay, but now we have to tackle the big myth. The thing that always comes up in forums online. The fear that heat kills potency.
The big one.
People are so worried that if the water is boiling or if they steep it for too long, they're just destroying all the active molecules.
And this is where we get to do some real myth busting. This fear comes from a misunderstanding of the chemical stability of psilocybin.
Okay, let's break it down.
We have to remember that psilocybin, the main compound in the dried material, is what's called a prodrug.
Meaning it's not actually active when you first consume it.
Exactly. It's pharmacologically inert.
Yeah.
Chemically, it's O-phosphoryl-4-hydroxy-N and dimethyltryptamine. That big phosphate group on the front is the key to everything.
It's like a protective cap on the molecule.
That's a great way to think of it. And that phosphate cap makes it incredibly stable. To become active, psilocybin has to be dephosphorylated. That cap has to be broken off to create the active compound, psilocybin.
And the data shows psilocybin is really robust against heat.
It is. It's stable up to around 220 degrees Celsius. That's over 400 degrees Fahrenheit. Your boiling water is not even close to being hot enough to destroy it.
So the hot water isn't a destructive agent. It's really just acting as a very, very efficient solvent.
Precisely. Think of it like this. All those active molecules are trapped inside these tough, chitin-walled cells. When you add hot water, The heat and the water work together to break open those cell walls.
And that lets the highly water-soluble psilocybin just dissolve right out into the liquid.
Right. The main benefit of using hot water isn't for chemical conversion. We'll get to that with lemon Tek. It's about maximizing your extraction efficiency. You want to get all the available compounds out of the solids and into the water before you strain them away.
So brewing a tea is about mechanical extraction and filtration. You get the maximum transfer of the good stuff while leaving the bad stuff, the chitin, behind. The hot water just makes that process faster and more effective.
The host is exactly right. The real utility of the tea is physical comfort. By removing the chitin, you save yourself from that systemic inflammatory response.
Which leads to a much cleaner onset. It might still be a little variable in terms of timing.
But the physical side is solved. It's a simple mechanical solution to a deep biological problem. It's elegant.
It is.
But what if you want to solve that second problem? The inconsistency of the onset and the overall intensity.
Now we're getting to the fun part.
For that, you need to go beyond simple filtration and get into some acid-catalyzed chemistry.
This is the transition we've been waiting for. If tea solves the stomach problem, lemon Tek solves the absorption problem. We are now moving from kitchen mechanics to some really advanced, verifiable pharmacology.
To really get lemon Tek, we have to go back to that prodrug concept one more time. Psilocybin relies on your body to transform it into the active molecule, psilocin.
Right, that dephosphorylation.
Okay.
It's usually done by enzymes in your gut and liver, mainly one called alkaline phosphatase. This enzyme is what snips off that protective phosphate cap.
And therein lies the problem that lemon Tek solves. Individual variability.
Everybody's different.
Everybody is different. People have different levels of that enzyme, different stomach pH levels, different liver functions. All these variables change the rate at which psilocybin converts to psilocin.
Which is why for one person it might hit in 20 minutes, and for someone else it takes an hour and a half.
Exactly. The lemon Tek hypothesis is kind of revolutionary because it says, hey, what if we just move that whole rate-limiting step outside of the body?
Could we convert the inactive prodrug into the active drug, in the cup, just by using a strong acid?
That was the research objective, to prove that a high level of acidity could act as a catalyst for hydrolysis, breaking off that phosphate group without any enzymes needed. And the data they got back is, well, it's just astounding.
Let's get into the experiment, because this is where it gets really good. The researchers took a sample of mushroom material. They used the Enigma variety, and they mixed it with Santa Cruz lime juice.
And they measured the pH. It came in at a very acidic 2.5. Then they just, measured the chemical makeup of the mixture over time.
So at the start, at time 0, the baseline, what did they find?
At T0, the mushroom material had less than 3% psilocin. So just as we'd expect, pretty much all of the potential was locked up in that stable, inactive prodrug form, psilocybin.
But the moment that acid got to work, the reaction was fast.
Incredibly fast. At T15, just 15 minutes into the soak, the conversion rate had exploded. Over 75% of the psilocybin had already converted into fully active psilocin.
75% in 15 minutes. That's incredible.
And it kept going. By T45 minutes, 45 minutes in, the solution had achieved over 85% conversion.
So this is it. This is definitive lab-backed proof. We're not guessing anymore. We know for a fact that a strong acidic liquid, like lemon or lime juice, acts as a powerful catalyst. It does the job that your body would normally do, but it does it right there in the glass, and it does it fast.
It fundamentally changes the pharmacokinetics, which is just how the drug moves through your body. When you drink that lemon Tek mixture, you are skipping the entire conversion bottleneck in your stomach and liver.
You're drinking the final active product.
You are. And the implication for consistency is just huge. You're no longer relying on your own unique biology to dictate the onset time. The conversion is high, it's predictable, and that leads to a much more consistent experience for everyone.
And the research didn't even stop with psilocybin. They looked at the other minor alkaloids in the mushroom, too.
They did, and they confirmed that the acid converts the entire spectrum of these related compounds into their active forms. This is a nuance that gets lost in most discussions.
So what else converted?
They found that baeocystin was converted into norpsilocin, and norbaeocystin was converted into something called 4-hydroxytryptamine, or 4-HT.
Okay, 4-HT. That's where the chemistry gets really fascinating, because as the source points out, 4-HT is what's called a positional isomer of serotonin. Serotonin is 5-HT.
Right, an isomer just means it has the same chemical formula, but the atoms are arranged a little differently. It's structurally very, very similar.
So when your body does the conversion slowly in your stomach, that process might be incomplete. It might leave some of these minor compounds still in their inactive form.
Exactly. But with a high-efficiency lemon tech, you're ensuring the maximum activation of all these related compounds.
And what does that mean for the actual experience? I mean, if you have a full spectrum of activated tryptamines, including one that's a cousin to serotonin itself,
Yeah.
that might feel different, right?
That is the hypothesis.
Yeah.
We know the conversion is faster and stronger, so the trip is more intense. But this full activation of the entire alkaloid spectrum could mean that lemon tech isn't just a dosage multiplier.
It could actually be changing the quality, the subjective character of the experience itself.
It's a fascinating possibility.
Mm-hmm.
The sour science is confirmed. Maximum yield, maximum consistency, a real chemical transformation right in your glass.
Yeah.
But all of this incredible efficiency means we have to immediately talk about the implications for safety and intensity.
So we've proven the efficiency. Lemon tech delivers active psilocin, and it does it fast and consistently. The main benefits are obvious. No more waiting around, no more guessing, and you get the most out of what you have.
But that speed is also intensity. Since your body is absorbing this huge concentration of active psilocin almost immediately, remember 75% converted in just 15 minutes, the onset of the effects hits like a freight train.
Right, it's not a gentle slope up, it's a rocket launch. The peak of the experience is reached very, very quickly, which kind of compresses the whole timeline.
That compression is the critical safety factor you have to understand. The user is basically experiencing the entire arc of the trip in a much shorter, more concentrated window.
So while the total duration might actually be a little bit shorter than just eating them,
The intensity of that peak is dramatically magnified. It's just a huge, rapid flood of active psilocin hitting your system all at once.
and this requires, the strongest possible warning for anyone who's a beginner or even just someone used to the slower methods.
Absolutely. You must reduce your dosage significantly when you use lemon tech. If you typically use, say, 2 grams of dried mushrooms.
You should probably start with 1 gram, or maybe even less, when you pre-convert it with acid.
Yes, the rule here is absolute maximum caution.
And that caution goes way beyond just the dosage. We have to talk about the critical drug interaction warnings that were in the research material. This is vital information for consumer safety.
It is. And the basic problem is the shared mechanism of action. Psilocin is structurally very similar to serotonin, which is, our body's main mood and perception neurotransmitter.
And psilocin works by binding to the serotonin receptors in the brain, especially the 5-HT2A receptors.
So if you introduce a powerful external agent like psilocin, which heavily messes with the serotonin system, while a person is already taking medications designed to regulate that same system,
The risk of dangerous and unpredictable interactions just goes through the roof.
skyrockets.
Yeah.
Let's break down some specific classes, starting with tricyclic antidepressants, or TCAs.
Okay, TCAs. These drugs increase the amount of serotonin in the brain. So what happens when you add psilocin on top of that?
The research shows that TCAs can actually amplify both the intensity and the duration of the psychedelic effects. You're getting a double whammy of serotonergic load.
So it could easily lead to a really overwhelming or deeply distressing experience.
Potentially, yes. Now, what about the more common ones, the SSRIs? Selective serotonin reuptake inhibitors.
The most common antidepressants.
Right. SSRIs work by increasing serotonin levels in the synapse. But, and this is key, long-term SSRI use often leads to the downregulation of those 5-HT2A receptors, the very receptors psilocin needs to bind to.
So if the receptors are downregulated, they're less sensitive to the psilocin.
Exactly. So the source material warns that SSRIs can actually reduce or even completely eliminate the psychedelic effects.
And that creates a really dangerous situation.
It does. Because a user might take a dose, feel nothing, and then incorrectly assume it was too weak, leading them to take a second massive dose to try and compensate.
Which would be a catastrophe.
The final and most severe risk involves MAOIs, monoamine oxidase inhibitors, and also high-dose SSRIs. This is where we move from psychological distress to a potentially life-threatening medical emergency.
Serotonin syndrome.
Serotonin syndrome. It's a toxic reaction from way too much serotonin activity in your nervous system.
And why is the combination with psilocin so high risk?
Well, MAOIs work by stopping the enzyme that breaks down serotonin, so your body can't clear it out efficiently. If you then flood that system with psilocin, a powerful serotonergic agonist, on top of that existing buildup, the whole system just gets dangerously overloaded.
You're blocking the exit door while cramming more people into the room. It's a recipe for toxicity.
The symptoms are critical to recognize. It can start mild with things like agitation, confusion, a rapid heart rate, sweating.
But it can get much worse.
It could escalate to high fever, severe muscle rigidity, tremors, and even seizures, loss of consciousness, and potentially death if it's not treated immediately.
The safety recommendation here, and we can't overstate this, is that anyone considering this while taking psychotropic medication must have an open and honest conversation with their doctor.
It's not optional. A supervised washout period where you safely and gradually stop the medication under medical guidance might be necessary to minimize the risks before any consumption is attempted.
This is what it means to be an informed user. The science gives us efficiency, but that efficiency demands extreme caution.
So to synthesize everything we've talked about today, we've confirmed two vital pieces of science for you, the learner, who's looking for a better experience.
First, the source of the nausea is, we verified it, the fungal exoskeleton, the chitin. It triggers an adverse immune response.
And making tea offers a simple mechanical solution, just strain out the solids.
And second, the problem of slow variable onset is solved by the sour science of lemon tech. We have real lab data proving that a pH of 2.5 rapidly converts psilocybin to active psilocin right in the glass.
This gives you incredible consistency and speed, but it absolutely demands that you reduce your dosage because of that magnified intensity.
We've armed you with the science to save your stomach and to understand the chemistry of speed. So the bottom line is,
If you want to save your stomach, strain your tea.
and if you want more deep dives like this, be sure to like and subscribe to Wonder Fungi for more science.
Now, for that final provocative thought we always like to leave you with. Remember that the acid conversion study confirmed that norbaeocystin converts to 4-hydroxytryptamine, or 4-HT.
The structural cousin of serotonin?
Exactly. Now, given that the slow conversion in your stomach might be incomplete, possibly leaving behind unconverted minor alkaloids, how might that full-spectrum conversion you get with lemon tech, the forced presence of active 4-HT, subtly alter the subjective profile?
Is the rapid, intense experience users report also chemically richer? Is it qualitatively different because of the presence of these fully activated serotonin-like compounds? What subtle differences might a chemically complete dose actually deliver?
Something to think about.
Thank you for joining us for this crucial deep dive. We'll see you next time.